Good afternoon, everyone. We are rolling along into the third session of Track A. This time we're talking about a data warehouse and why your definition of it might be wrong. It's my pleasure here to introduce Paige Roberts. She is an engineer, a trainer, a support technician, a technical writer, a marketer, a product manager, and a consultant, all in one.
Not all at once.
She has built data engineering pipelines and architectures, documented, tested open source analytics implementations, spun up Hadoop clusters, picked the brains of stars in data analytics and engineering, worked with a lot of different industries, and questioned a lot of assumptions. So today, Paige will be talking to us about a data warehouse. And with that being said, Paige, I hand it back to you.
Hi all. So as he pointed out, I have been doing this for a while. Decades at this point. So let me there we go. All right. So I assume you guys can see this. Your definition of a data warehouse is probably wrong. Now, the reason I named this is because I came across this definition of a data warehouse. This is actually a little simplified. It was a little more extensive than that, but I came across this on the web and I went, okay, that sounds right. And then I really looked at it and I went, and everything about it is wrong. It's like I would have thought this was correct a few years back, and now it's like I realize that it is completely not. Data warehouses, the architectures, the analytical databases at the heart of them, they've all evolved. It's all changed, and the old definitions that are still in our brains are holding us back. So I think we need to move forward and kind of learn what's different. So that's, if you're looking at this and you're thinking, oh, that's probably right. It looks good to me. What's the problem? Then this is your lecture. This is the thing where you get to learn something. So first of all, it's not just the things in that definition that I have in my brain. I also have things like, data warehouses have a star or a snowflake schema. They're really expensive. Storage and data analysis, both just crazy expensive. And there's always more people that want to use them. And, you have to manage that really carefully because, somebody could throw an ad hoc analysis at your system and just completely bog it down. And, your executive could be in some big, high, important meeting and all of a sudden his dashboard doesn't work, something like that. It's like, you got to really restrict what's going on there because you can have too many parallel users, you can't have too many parallel jobs. You've got this ETL concept. It's like you gotta feed that analytical database with ETL, and that takes a while, to do all that data transformation and get the data in. And again, you can't do it in parallel. I mean, it might slow everything down, so you got to do it at like 3 a.m. So you can only do it maybe daily. The data is always kind of stale. You spend a lot on consultants to tune it because the most important thing about a data warehouse is fast, efficient analytics, obviously. Well, then you want to pay somebody to make it fast, to make it efficient, right? So I guess, if you kind of see all of these things and you're thinking, that's the data warehouse, that's the way that works. Let's talk about what's changed. So one of the things that's changed is the environment has changed. So the data volumes have changed. Obviously, everybody's hearing about big data for the last 10, 15 years. And that's great. I mean, Facebook and Twitter and all those guys came along and they had more data, and there was, click streams on websites and some things like that. And there's a little more data. And then along came IoT and it was like, wow, tidal wave of data. And it's like, what do we do with all this data? Plus, there's more and more drive to become data driven, more and more push for companies to use analytics all across the company, not just the executives, not just the analytics department, not just this little small team. But everybody in a company should use data to make the decisions. I mean, the tech support guy ought to be able to pull up the data on his customer to see what their problem is before he even asks them, and have they had this problem 4 times before, or is this the first time that they've called? That's important. You get better customer experience, you get, you reduce churn, you get better, there's a lot that you're trying to accomplish. And you have to be able to do a lot of concurrent jobs, a lot of concurrent users. And I do mean jobs. It's not just users, not just people that want to hit that database. You've got that ETL. It's like, I've got to be able to pull in my data. Data doesn't wait until 3 a.m. If I want to get current data, if I want to approach real time, because my analytics people want faster response. They want that data fast, and they want their answers quick. And I got to get my data in at the same time. So maybe I have to do ingest in parallel with query. Maybe I need to pull the data in and then do the data transformation and preparation inside the analytical database. The demand is just huge. So we have more and more data, more and more people wanting us to do more and more analytics in less and less time. And that pretty much wraps it up. And they want us to accomplish things that we never had to accomplish before. I mean, predictive maintenance. I want to know when something's going to break before it breaks. I don't just want to know what's wrong with it. I want to know what's going to be wrong with it so that I can fix that before it breaks down. I want to detect fraud. I don't want them stealing money from me. I want to figure out that they're trying to steal money from me and keep them from doing that. So that's more fraud prevention, not just detection. I want to analyze health records for everybody in the country so I can figure out, who's going to die of COVID, who is more needs the vaccine first. That's important. That's key. I need to be able to improve my customer support, recommend the next product. It's like all of these things require good analytics, and that's what data warehouses are for. So what changed? What's new? What's different? I already told you that old definition is wrong, and here's why. Let's talk about what's right. So what does a data warehouse look like now? So what is a correct definition? Let's start with infrastructure. So in the old days, everybody has this concept of a data warehouse as a thing, and I'm going to buy it, and I'm going to have this data warehouse. Look, I bought a data warehouse, and I have it. And a lot of the vendors sort of jumped on that concept and used it to pull a fast one on a lot of people. So they had this concept of, look, here's an appliance. It has it has your data warehouse on it, and it's a piece of hardware, and you buy it, and now you have a data warehouse. Yep. Oh, so I can do analytics now? No, you can't do analytics yet. You got to put data in it first. Well, how do I do that? Oh, well, you have to buy this other software to get your data from all your silos and transform it and clean it and make it perfect and get take out your duplicates and fix the fact that you got 3 different addresses for the same guy and do all this stuff and then put it in. Well, where do I get all that? Oh, you got to buy that. Could I just buy it from anybody? No, you got to buy it from us because you bought our appliance and only our stuff works with the stuff that's on this appliance. So I got to give you more money, right? Okay, so I give you more money. Now I can do analytics. No, now you need something to do visualization. You got to have a BI tool that'll show dashboards and let you drill down and throw SQL at your appliance. That is your data warehouse. Well, wait a minute. Isn't a data warehouse designed to do analytics? How come I can't do analytics with this thing that you sold me unless I buy all these other things from you? And I can only use these other things because I bought this. Okay, so everybody understands the concept of lock-in, right? Okay, we're not going to do that again. So now You go to the cloud and you're like, hey, we're going to sell you a data warehouse. Look at this. It comes on this infrastructure and we're going to manage the infrastructure. So the hardware taken care of for you, the software, you just pay us and you get a data warehouse. So I can do analytics, right? No, you have to also pay us for the services that get the data in there and the data and the services. Oh, well, you have to use our services because you're on our cloud. This kind of sounds familiar to some of us. And this whole concept of lock-in of and this concept of a data warehouse is one thing. It's just, you just buy it and you got one. And that's not the way that is. So a data warehouse is not a technology. A data warehouse is an architecture. It's an enterprise architectural design. It has everything from, I have a whole bunch of different sources and I need some software to pull those in and combine them and put them into an analytical database, which is the heart of your data warehouse. Yes, but it is not the whole thing. The whole thing is the architecture. And so you get all the data in there and you got to be able to do all your analytics there, and then you got to be able to visualize it, and it's got to sit on some hardware, and maybe that's in the cloud. Maybe it's a Hadoop cluster. Maybe it's some specialized hardware. Maybe it's, simulation from some software like MinIO or VMware where they're simulating something else. You can do like private cloud. All of that, this entire slide, that whole thing, that is a data warehouse. That architecture, that concept of I have to have all of my data from multiple sources combined into a database, which sits on some hardware, and then visualize that and use that to do active drill downs. Now, I might also, for instance, have this in a Jupyter notebook. And maybe my active visualization is to show me a graph for exploration to see correlations. So there's more to it than just, I want a dashboard for my executives. But the big thing is I can put it all over the place. Don't feel like you have to be locked into one particular location. You should be able to put it where you need it. If I have a Hadoop cluster already and I want a data warehouse, I put the data analytics database on that Hadoop cluster, and I use that data, which I've already got the pipelines pulling in. It's like I don't have to rebuild from scratch just because I want to use a different database. It's like the rest of your infrastructure, the whole, it's there. There's no reason to redo it. And there's new ways to do it. You could do it on the edge. You can do it in the clouds. Just be careful not to get locked in. The clouds are great, but Amazon might be great this week and Google might be great next week. Don't get locked into one or the other. Be able to be free to go where you need. And if regulations change and you have to pull it on premises, you should be able to do that too. Your data warehouse shouldn't, your analytical database shouldn't lock you into having your entire architecture in one place or sold to you by one vendor. So, new ways to store structured data. This is another thing. So in the old days, we stored our structured data in one way. And the whole idea behind this was very efficient storage. The idea was to make the storage as efficient as possible, to only store things one thing at one time as much as possible. I mean, sometimes you had to store things twice in order to show the relationships between tables, but the idea behind a table was that everything in it was unique. It was completely different from this other table and from this other table and from this other table. Okay, so that's really efficient for storage. Storage is not the goal of a data warehouse. Efficient storage is not why you have a data warehouse. Analytics is why you have a data warehouse. Doing analytics well, doing it at great performance, doing deep analytics, doing different kinds of analytics. That's the purpose. So this was not the best way to store data because it was all about how to store data efficiently. It wasn't about how to do analytics efficiently. So new data warehouses have new ways of storing things. Now, one of those big things is columnar. So a long time ago, Michael Stonebreaker and some other guys came up with this concept of let's take data and instead of storing it this way, I'm getting notifications. Instead of storing it all this way, so I have 100 columns and I store it like that because they're all related to each other. How about I store a single column and I maybe store the columns together, but I only have to read one column at a time. And this means if I want to do analytics on something like sales by region, well, what do I need? I need the column that has my sales numbers and I need the region. And that's it. Now there may be 50 other columns in the table that has those two that I need, but instead of reading 50 every single row, how about I read 2? Now I've not magically, but I've very intelligently shrunk down the amount of read that I have to do the analytics that I need to do. And that's tremendous. That makes such a big difference. And if I sort it, hey, even better, because I want to do sales by region. Well, let's sort it by region. That makes my analytics like a piece of cake. And if I store my data in the way that I'm going to analyze it, that is the big message here. Store your data the way you're going to analyze it. So first of all, stored in columns. You don't have to read a bunch of data you don't need to read. All right. Second, if I've sorted it, what that really means is each individual column has only one kind of data in it. Only dates, only numbers, only characters, whatever. And we have dozens of compression algorithms now, good, modern, strong algorithms for compressing data like crazy. But most of them are based on what the data type is. Well, if I've stored only one type in a column, then I can compress the crap out of that. If I use the right algorithm, I've got some smart AI in there that goes, this data type, this algorithm, boom, compress. Voila. I have efficiently stored my data without storing it in this crazy snowflake thing. Instead, I'm storing it in columns and they are compressed. Well, what if I have to uncompress it, then do my analytics, then compress it again? Okay, that's a pain. Well, why can't I just do analytics on the compressed data? Why not? There's no reason why you can't. Good modern analytical databases can do that. Or they have added on that capability over time to do that. They've either been built to do that from day one, or they've seen the writing on the wall and they've added that as a thing. It's like, oh, we can store your data in the old way, or we can store it in columnar and we can compress it and do some cool stuff. And if it's sorted, you can compress it even more. All right. So what else? Well, optimize your storage for your analysis. Great idea. Yes. Well, that means if I have a fact table and 3-dimension tables and I have to join them together to analyze 100 rows to do my analysis, how about instead of doing all those costly joins ahead of time, why don't I just store the data that way? Since that's the way I analyze it, why don't I just store it like that? Or if I do sales by region, how about I just store sales numbers and region together with sorted by region? So when I throw that analytics at it, boom, it's easy. Instead of having to go and find that and read a bunch of other stuff, how about I just store that for that analytics, ready to go? Well, what if I do sales by month or sales by quarter? Well, how about I store it again, sorted by date? And maybe I aggregate it so that, I get daily sales numbers. Well, why don't I just, since nobody looks for daily sales numbers, everybody wants to know by month or by quarter or year over year or whatever. Why don't I go ahead and aggregate that by month and store it that way? Well, what if next time I want it by week? Well, keep the original data, have a copy. Oh, now you've got copies. You got data copies all over the place. That's not efficient for storage, but storage is the goal. analytics is the goal. So if I store multiple copies of the data, each one optimized for a particular type of analytics, what am I doing? I'm optimizing for analytics, not for storage. So this is the old way. There's the new way. You store it either aggregated, you join a bunch of tables together if you need to do 100 columns at once, or even 10 columns with from 4 different tables. You store them together. You store data duplicated and sorted in different ways because there's different ways you might want to analyze it. And that seems like a great idea, except for the fact that you've bloated your storage up hugely because you got all these copies of your data. Well, Hadoop stores everything 3 times anyway. Why? Because a node might go down and you want your data safe. Well, what if you stored that data multiple times, sorted different ways, selected different ways, and one of your nodes go down? Doesn't matter. You didn't lose anything because you got other copies. You just create another storage that's sorted the right way for that analytics. And there's one more thing: compression. It makes it all efficient. So even though you're storing multiple copies, it still stores efficiently. It still stores more efficiently, in fact, than the way that was optimized for storage efficiency. And that's the crazy thing, because compression makes such a huge difference. So if I can compress by, if I have 60 terabytes and I can compress that down to 10 terabytes, well, even if I store it 3 copies of everything, I've still got my 60 terabytes down to 30 terabytes that I'm operating on. So I still need half the hardware to do the same job. And it's going to be faster, because if you store your data optimized for analytics, your analytics are more efficient and quicker, and you get better response time. And that is the fundamental concept of changing the way we store data. All right, so what else? New types and amounts of data. Like I said, you had this tidal wave of IoT data. It's like it's just blown away everything else. There's so much of it that that it leaves everything else in the dust. Our old concepts of big data are really kind of small compared to the meter data coming off of all of the meters in every house in the United States. And then I'm trying, a utility company, and I'm trying to do smart meter. That's going to require a little bigger database than I had before. I'm trying to do smart agriculture for these guys in their tractors. It's like they got to optimize crop yield so we don't starve. That's kind of important. All of this stuff, optimizing IT operations, fixing things before they break, catching cybersecurity intruders, geospatial analytics, trying to figure out where, if I'm a telecom, where do I put my next network tower? If I'm Uber, how do I optimize a route to get you a car in under 7 minutes? All of this stuff, it requires you to be able to use new kinds of data. Semi-structured, log data, text data, all this unusual kinds of data, not just the old school structured transactional data that we were used to. You still need that. I mean, that didn't go away. It's just we just piled more on top of it. So that kind of gives you the idea. It's like we have to be able to scale, both for tremendous amounts of data and for more and more people and more workloads. And to do that, Hadoop has already taught us. The one thing that Hadoop did extremely well was store and process a lot of data. And the way it did it was affordably. That's an important point. It's like our old data warehouses, they stored and processed a lot of data, but you had to have some bucks to make that happen. Now you can go buy a server, online. I apologize. I swear I do not have COVID. I just live in Texas and it's spring. Yeah. So if you can expand your capability by buying cheap hardware at the local store, the big box store, or online, that gives you a tremendous capability to expand. To be able to both use more and more data, to ingest in parallel with query, to do old school BI and machine learning at the same time, to do a lot of different things. And one of the things, I work for Vertica. One of the things that we did smartly on this is we didn't build a master node or a leader node. So there's no single point of failure. And I think that's one of the things that is different about us as opposed to other databases. But most of your databases, most of your good analytical databases that form the heart of data warehouse architectures now have this capability. So what other capability they have? Well, a lot of them have the ability to query not just their own structured format, but also the ability to query message formats like JSON and Avro, text formats like CSV, long-term storage formats that have these complex hierarchical formats like Parquet, Orc. They have maps and arrays and structs and things like that. If you have a single capability that can query all of those things, you have the ability to do analytics without essentially having new silos. That's the thing that you have to be careful with is before all of our silos were transactional, now we have data silos that are a whole lot of other different types. So you need to be able to bring them all together. That's a fundamental data warehouse principle that has not changed. New types of analytics. So one of the big things that has changed is instead of doing just dashboards, we have these data scientists, we have a whole team of people who are trying to do a different kind of analytics, and they're trying to do more advanced analytics. And even the business intelligence folks who have been doing our descriptive analytics for years would now like to do some predictive analytics so that I not only know how I did this quarter versus last quarter, but I can maybe predict how I might do next quarter. And you can accomplish a lot of things that you couldn't accomplish before. Prevent churn, you can segment your customers, so you can do targeted marketing, you can make decisions on what works better for click-through rates. You can predict failures before they happen. All of these things require machine learning, not just old school BI, not just the standard things that your visualization tools used to do, but now there's some more advanced visualization tools that can accomplish some greater things. Plus you have things like new tools like Jupyter and your other notebooks and Python, R, things like that. It's like, well, what does that have to do with a database? Well, the answer is nearly every analytical database out on the market today, all of the big ones have those capabilities, or they have the capability to add those on. You can add those to ones that don't. Like Google BigQuery doesn't come with it, but you can get Google ML and add that on. Now, Vertica comes with it built in. Some of your other ones come with it built in. You have things like MindsDB, which has the capability and will add on to other databases that don't have as much machine learning capability out of the box. Things like SQL Server and Snowflake and Maria and stuff like that. So why would I want to do that in a database? What's the advantage? Well, I think the biggest advantage, I mean, there's some listed on the slide, you can read that, but the biggest advantage isn't on this slide. And that is, my background is as a data engineer. I used to write pipelines. I used to do that ETL. And the thing about that is it's a lot of work to get all of that data to where you need it, to get it clean, to get it deduped, to get it right where you can analyze it. If I have to do that twice, once for the BI team and once for the data science team, that's double the work. And nobody wants to pay me twice. That's a fundamental truth of all of your businesses, is that they don't want to have to build 2 data pipelines for everything. And both your data scientists and your BI team need all of the data that they can get their hands on, because that's what we run on. It's like you can't accomplish your goal unless you can do all of it in one place, and that's huge. So being able to do the entire end-to-end workflow, from exploring your data to preparing your data to modeling to evaluating to deployment to management, all of that in one place is tremendous. But the other aspect of that is being able to use your tool of choice. If I'm a BI person and I'm used to using Tableau, I should still be able to use Tableau. Tableau throws SQL at my system. I know SQL, I understand it. I'm going to use Tableau. I'm going to use SQL. I'm going to get my job done. And maybe now I'm going to train a random forest model. Maybe I'm going to do some predictive analytics with linear regression. I can do that. Well, maybe I'm a data scientist. I'm used to using a Jupyter notebook. I'm used to typing in Python and getting everything I want in there. Why can't I connect to the database where all my data is and use that MPP architecture that works in parallel instead of trying to write parallel code? Because, oh my God, just write simple code and let the database handle operating on data, which, it does that pretty well. So let's wrap this up. So what's wrong with that old definition? Okay, data warehouse is a technology. I think we've already figured out a data warehouse is not a technology. A data warehouse is an architectural design. The analytics database, that is the heart of that architecture, and that does the actual analytics, but it is not the complete architecture. I'm a little guilty of that one myself. I have occasionally called an analytical database a data warehouse because you tend to get those mixed up in your brain. It aggregates structured data from one or more sources. Well, actually, the one or more sources, no, that's not right. No, if nobody ever aggregates data from one source, why would I need a data warehouse if I only had one source? It aggregates all kinds of data, semi-structured, structured, huge volumes of it from many different sources, so that it can be analyzed, yes, but not just old school business intelligence, tell me what happened, analyzed, but also predictive analytics, prescriptive analytics. Let me recommend what you should do. What's the next good idea? That's data science. And it's for business intelligence, and it's not just for business intelligence. Sure, it's still for business intelligence. A data warehouse is still for business intelligence. That hasn't changed. But it should also be able to do that prescriptive and predictive and future. So here's a new that I made up by myself. An enterprise architectural design with an analytical database at its heart that unites. So it will improve decision making. And that last bit, both human and automated, because people make decisions, yes, but nowadays artificial intelligence makes a lot of those decisions, and people figure out the thresholds and say, well, if it's above this, I would always do this. Well, what do you need the person from? Because once they've told you that, you can build it into the application. And now you've made the application smarter because you took some of the brilliance of your people and built it in. So it's affordable at unlimited scale. It can do a lot of concurrent jobs, a lot of concurrent users. It can do advanced analytics and machine learning, and it doesn't lock you into a particular place to do all your stuff. I got to say one thing, egress fees are the most nutty invention of the modern day. I have to, first time I heard that, I thought it was a joke. Unfortunately, it is not. Somebody does in fact charge you to move data. So if you want to learn more, we have a booth. We're one of the sponsors. We also have a free academy that lets you go and get training and certification and doesn't cost you anything, which is pretty cool. So that's my thing. So let's jump to Q&A if there is any time, because I'm over a bit.
Perfect. Thank you, Paige. Thank you for making through the presentation. I do have a couple questions here. We will be done in a couple minutes, but let's go through a few things.
Well, I'll jump. I forgot to say I'll jump over to the networking lounge for the track A after this. So if we don't get to it, there you go.
Perfect. Okay. So first question here from Rebecca. Can you clarify the differences between a data warehouse and a data lake?
Nowadays, the differences are becoming less and less real. I think a lot of the data lake vendors are calling it a lake house, which I think is stretching your metaphor a little far. Almost everybody else is calling it unified analytics, but it's the same concept. Have one query capability that can query your structured data, your unstructured data, your semi-structured data, all your data from one place. And that's the concept of, I think a lot of your modern data warehouses are just absorbing the capabilities of the data lake. And the data lake is trying really hard. To be fair, all your data lake vendors are working their butts off, trying to do the same thing. It's just that your data warehouse vendors, I said it again, analytical database vendors, they have about a 10-year head start. They've been doing it longer, and things like maturity and governance and reliability and all those things that the data warehouse already had, the data lake guys are now trying to get as fast as they possibly can. Whereas all the analytical database folks had to add on was the ability to query more stuff. So they had a shorter run. I think everybody's running towards the middle, and we had sort of a little bit of a head start, maybe.
Got it. Makes sense. Okay, let's do one more question, and then we'll finish up here in 2 minutes. Uma asks about lock-in. He's saying that whatever ETL tool you choose, whatever database you choose, whatever cloud you choose, you're locked in. So how do you avoid lock-in?
I think there's two things. One is, if I choose a particular ETL tool, I am not locked in to using a particular database. All of your ETL tools will let you use whatever database you want to use. If I choose a particular database, it should not tell you which ETL tool you can use. If I choose a particular database, it should not tell me that I have to deploy on this particular cloud. It should not tell me that I have to use this particular service. It should sure as heck not charge me a fee to take my data out of it and go use another database. And I think that's huge. The ability to use whatever infrastructure you want to use, the ability to go wherever you want to go from one cloud to another cloud, hybrid, multi-cloud, whatever. It's like your choice of software should not determine your hardware. Your choice of database should not determine your other services that go around the database. That's really the thing. It's like, yes, if I choose a particular database, I'm pretty much locked into using that database. But that shouldn't lock me into everything else in that entire ecosystem.
And I think we'll finish here, give you a break. But
sorry about that.
No worries. Thank you for the great presentation. Paige will be available in the networking room, everyone, so you can follow up with some one-on-one questions. And that concludes our session here. Our next session will be starting in about 20 minutes in the same track. So hope to see you there. Thank you again, Paige.